Today we are going to discuss a bit about projectile. Apa kita ada kat sini? Okay, so what is a projectile? Siapa baru masuk ni? Sekejap Correct. Okay, so kita lukis paling mudah. Right. First, when we try to discuss projectile, we need to know about free body diagram. Projectile need to be free body. Okay, free body. Paling mudah for us to define what is free body means it cannot produce force on its own. No internal force. Ni maksud dia. So free body only subjected to several properties. Okay, kita lah ni objek. Okay, so free body, apa yang dia ada? Satu, it can has externally. This is the first one. It can react to external force. Number two, it will be subjected to friction. Depends on the direction of the force being applied. Dua. And yang ketiga, it will react to gravity at all time. Ni bila kamu ada sesuatu and comply to these three values. It can have force from the outside. It has friction based on the force that being applied, and then it has it responds to gravity. So itu adalah free body diagram. Okay, example, bola kena sepak, it travel. That is a free body diagram. Shuttlecock kena pukul dengan raket, travel. That is free body diagram. Frisbee being thrown. This is free body diagram. Dia mesti bergerak, and that pergerakan caused by external force, not internal. Okay, aeroplane, not a free body diagram because it has thruster. It has engine that enable this plane to maneuver. Free body dia tak boleh maneuver. It just follow a certain pathway. Okay, manusia falls from the plane downwards. Free body diagram. Jatuh ke bawah kan. Tu masa dia jatuh tu free body because it cannot change direction on its own. Tak boleh. Tapi bila dia pakai wingsuit, dia can change direction to left, to right. Dia dah gliding. Okay, they are gliding. We can have a projection, but the projection is going to be quite haywire. It's still free body diagram because dia tak ada internal force yang membolehkan dia untuk daripada bawah, contoh macam ni dia jatuh, suddenly change movement there. Dah sampai tepi tu tak sedap, change upwards. Tak ada. Tak boleh. Because when we talk about free body diagram, first it has only these three things. 1, 2, 3. And then it only move within two planes sahaja. Horizontal plane and vertical plane. Kalau dia bergerak macam ni, yes, this is free body. Example, we have a ball, it being kicked, cause the ball to travel. So this is point A, this is point B. Between point A to point B, this is the horizontal aspect of the motion. And then from the base of the motion towards the highest peak, this is known as the vertical aspect ataupun component. So free body only subjected to vertical and horizontal component. Mesti ada dua-dua ni. Cuma kadang-kadang kita tak sedar. For example, we throw something upwards. Kita baling guli ke, duit shilling ke, and you are going to notice it goes downwards. We throw it up, it goes down. So this is A, this is B. This is horizontal component. And from the base to the peak, this is vertical component. Ataupun kita ada dekat atas rumah, duduk atas ceiling kan. Duduk kat atas bumbung tu, we throw hammer down. Kita kat sini. Pak, dia masih ada. So from the start of the pathway until the end, this is A, this is B. So we can make an imaginary line. This serves as the horizontal component. And the imaginary line is the vertical component. Ataupun kita main basketball. We play basketball. Have a ball. We have a basket. And you throw. So this length, up until the length of here, is your horizontal component. And the peak of the pathway to the base, this is vertical component. So make the basketball ball a free body diagram. Ni hammer become free body diagram. Duit shilling become free body diagram. Because along the way, along the pathway, this is the pathway, or dia punya nama dia parabolic. All of this object within this parabolic or this parabolic or this parabolic, they are only subjected to force externally, friction in vice versa direction, and gravity. And the movement only have two planes, vertical plane, horizontal plane. So they are free body diagram, and combination of all these, we call it as projectile. So hampir segala benda yang bergerak dekat dalam dunia ni is actually a projectile. Cuma kadang-kadang mana ada kan kita main main frisbee. We throw the disc. Sometimes you see that you observe based on your observation, you see that the disc move in a straight line. There are no parabolic or there are no sloping down. It moves in a straight line. But if we take a good look, we are going to see a quite smooth curve. There are vertical component and horizontal component involved in the projection. Okay, so nama lain dia ialah parabolic, ataupun lagi satu we can call it as trajectory. Ni adalah tiga nama untuk jalan ini. Okay, this is quite a balanced quite a balanced projection. This is more towards a vertical projection, and if we goes like this is more towards horizontal projection. Regardless, it is a projectile because they are free body diagram and there are properties that meet a projectile. Two projectile secara asas. Okay, ni projectile. Okay, and then this is some of the example lah. Ni pole vault, dia pun projectile. Skydiver, manipulate, okay, compound velocity to land close to the target. Okay, kita kata skydiver tu berubah-ubah tempat, but it is still a projectile. Let's see. Sky diving. Goes here, change direction a bit. Goes here, change direction a bit. Goes there, change direction a bit. Goes there, change direction. Goes there, and then land. Is there any internal force causing this action? Ada tak internal force yang menyebabkan pergerakan ini menjadi begini? Or is there manipulation of the air, the pressure? What caused this curve? Is it internal force or is it the change of wind current? Mana satu?
Wind.
Wind. Okay. Can this skydiver, bila dah terjun kan, can he or she goes like this? Source to atas. Means he keep on going upwards. Can he do that?
Cannot.
Cannot. Maksudnya dia masih lagi subject to gravity. It has friction and at the same time force. So this is a free body diagram. And about the motion itself, okay, about the motion itself, it still have those two components. The first one, if this is the land, so we are going to see some dotted line down, some dotted line parallel. So this is the intersection, and this will serve as the horizontal component. This will serve as the vertical component. Ada terus 5 benda yang kita perlukan. So human falling down is an example of free body diagram. So this is a projectile. Susah sangat nak faham projectile kan. Benda yang tak boleh ubah direction dia sendiri projectile. Okay, you naik glider. Okay, glider. Let's say you play extreme sport. Kita ada satu nama dia glider. Mungkin ramai orang pernah nampak benda ni. Okay, selalu dia main dekat jugra. And then you're going to be hanging underneath that. You're going to glide down. However, there are certain glider known as paraglider kalau tak silap. Dia ada motor. You are not going now you are not going to lie down. Instead, you are going to be sitting on some sort of contraption where at the back here it has fan which able to produce thrust. So if we compare glider versus paraglider with engine, this one is a free body diagram which resulting a glider to be projectile, but not in the same case as paraglider where you can manipulate your movement based on thrust. So bila ada thrust ni, maksudnya benda ni menghasilkan internal force to change the course of action. So this is not a projectile. Pasal tadi kan kita ada objek, kita ada force external. Now dia ada force internal, and then friction, and then gravity, no external force. That is not a projectile. Itu kita beza dulu. Projectile and not a projectile. Okay, and then component only, vertical component only influenced by the gravity but not horizontal. Okay, maksud yang ini kan, maksud statement ni, vertical component is influenced by gravity and not the horizontal. The meaning is something like this. If you have two condition of ball, satu, bola yang kamu lepaskan sahaja daripada satu ketinggian. Number two, bola yang kamu lepaskan horizontally. This is totally vertical, this is totally horizontal. These two ball is going to reach the floor at the same time because of one thing. Because of this value. 9.81 meter per second square. As long as you are in the earth, you're going to get this value from gravity. So sometimes they put it as G, sometimes they put it as A. Sama je benda ni. Because G is actually an acceleration downwards. How you know that? Ini. That is the main reason which cause these two condition of ball to land on the floor at very similar moment. Although this one has both vertical and horizontal component, this one only has vertical component. Either way, since the gravitational acceleration is equal, these two things is going to reach similar. Tu dia, ni konsep pertama. Okay lah, ni contohlah dia buat. Kalau tak percaya nanti kamu buat. Cari bola yang sama berat Jangan pula satu tu pakai guli, satu pakai bola sepak. Kalau dua-dua bola sepak, make sure it is the same weight. Timbang. Ataupun cari benda yang memang kamu tahu dia sama. And make sure the shape is similar. Jangan pula kamu pakai macam shuttlecock where it has a lot of influence of friction. Baling ke depan dengan lepas ke bawah, the friction values is going to be different. Nanti kamu cakap tak dapat pun, bulu tangkis yang jatuh macam tu sampai dulu. Yang tu lambat because of friction. No. Try to find something in similar nature. And then you are going to see both of this ball, if being dropped by at the same height, it will reach the floor at the same time. Because in projectile, the only thing that pull it down is gravity, and the value of gravity is equal along the projection. Along here, and I say projection, ni kan, along here, the gravitational force for this one is actually similar. Tak kisahlah dekat mana, atas peak sekali ke, dekat sini ke, dekat bawah ni ke, the gravitational force still similar. So to prove that, they come up with this experiment. Nak buat boleh, nanti cari bola ke apa-apa yang sama. Okay. Tak payah. This is, no, don't need this, we don't need that. Okay, another one. Okay, another one you need to know is this one. When we talk about projection, okay, projection, trajectory. Vertical component, horizontal component. Other than this, there are several things that you need to focus on. The first one is the peak of the trajectory, or known as apex. When you see the apex, when you see or heard apex, it means that it is the peak of trajectory, apex. Itu yang pertama. And always remember, an object, when it moves through a trajectory down, okay, here the velocity is always zero. Jadi kalau kita baling satu objek kan, kita baling bola, dia naik sampai satu tahap sebelum dia turun, that is the apex. You are going to see that kalau kita buat kamera, high speed camera, we can see that it stop, because that is the turning point before it goes down. Always remember, velocity at the apex equals to 0. Always equals to 0. Okay. Velocity dekat bawah ni, okay, velocity at the starting is V sin theta. Velocity dekat bawah, ataupun kita panggil dia sebagai velocity initial, or V1, is V sin theta. Pasal apa sin? Pasal bila kita cerita projection, it involve It involve It involve angle. Okay, it involve angle. And then, if we have this kind of projection where it starts and ends at the same level, the time taken for the object to reach apex, okay, kita namakan dia sebagai T up, is always equals with the time taken for the object to travel from the apex down, where we call it as T down. Ini konsep dia. Okay, this is the concept. Alright. Next one, Factor. Factor influencing projection. There are 3 factors. Number 1, angle of the projection. It determines how far it goes. Whether it's going to be horizontal projection or it's going to be vertical projection. Kalau angle dia besar, vertical projection lah jadi. Kalau angle dia kecil, horizontal projection lah jadi. That is the first factor influencing projectile. Factor number 2 is initial velocity. If the angle is similar between trial, but we have different initial velocity, the most highest velocity will give you the longest horizontal component. 2. And then for the third one is known as relative projection height. Relative projection height is the difference between start and ends. So there are 3 conditions for relative projection height. Relative projection height. The first condition, which start and ends is equal. Macam tadilah ni. Start and end. So you're going to get quite a good projection. And here, in order to get the longest range, the angle need to be 45 degree. In order to get the highest or the longest range. Okay. Condition number 2 is when starting position is higher compared to ending position. Example, macam kita main golf, betul lah. Kita tee off tinggi. And then, flag rendah. Di sini. So, this projection is more towards horizontal projection. Where the better angle is actually less than 45. Katalah kita bagi 45, dia akan dapat macam ni. You're not going to reach the target. So you need lesser angle. So lawan dia is the third condition where the starting position is lower than the ending position, such as kita main basketball. This is the starting. So you need to have quite a high loop where this is more towards vertical projection. Kenapa nama dia horizontal? Because horizontal component dia lebih besar daripada vertical component. Ni horizontal component dia. Okay, daripada sini horizontal. Vertical component dia apex dia. Mana apex dia? Ni apex dia. Okay, daripada situ vertical component. Here you have higher vertical component compared to horizontal. So this type of projection is known as vertical projection. This type of projection known as horizontal projection. This is quite a balanced projection. So for the third case, the desired angle to reach target is actually more than 45 degree. Dia akan dapat macam ni angle ni kan. So kita akan dapat lebih pada 45. If 45, sas pergi bawah gitu. This is the 3 main factor which influence projectile. Okay, 3 faktor yang mempengaruhi projectile. Okay, tadi cerita apex. So we have projection speed, we have projection angle, and we have relative projection height, relative height of the projection. So that 3 things determine how far it goes, and it determine the shape of the projection itself. So sometimes we try to reach higher level. Jadi angle dia kena besar. Sometimes we try to reach the furthest. Means we don't need quite a high angle. Sekarang baru kita cerita nak pergi jauh ni. berapa relative height. If the start and end point is equals, and then 45 degree will be the best angle in order to reach that particular distance. Tu projection angle and this is the parabolic line benda yang kita belajar tadi lah. Ni example range covered by maximum height. Maksudnya angle yang berbeza. If the angle is too big, landing. If the angle is too small, pun sama. So we only have one angle ni dekat sini. Yang ni, it reach the furthest. And this is this angle is actually 45. Okay, 45 degree. Ni contoh. Contoh lagi dia bagi. Okay, angle 10. Projection apa ni yang ujung ni, projection projection speed 10. Maksudnya speed dia sama, angle dia berbeza, so distance dia berbeza. So you can see 10 degree dapat yang ini, and when you goes too much dia akan balik tempat yang sama. So we only have one which is the furthest, 10.19. This one is 45. Nanti saya tunjuk kamu macam mana, kenapa 45. Okay, ni tak payah. Okay, benda yang sama, so please read through this one again afterwards. This is just an example. Okay, we have speed, we have velocity, the same thing, and then finally is the relative projection height. Ini dia, relative projection height 0. This is relative projection height higher. This is relative projection height lower. So this one 45 will give the most effect. This one less than 45. This one is more than 45. You are going to get to the target. Okay. Kejap benda yang sama. So I'm going to skip this one. Okay. These three equation kita hold dulu. Saya nak tunjukkan kamu satu benda lain dulu before we go to this. This equation is known as equation of constant acceleration. Okay. So this equation, penggunaan dia kita hold dulu. Okay, apa saya nak tunjuk maksud dia dulu. We go by projection. Okay. Please remember what I said earlier. We have T up, we have T down. Meaning that we have one part, we call it as the up phase, and then we have another part, down phase. Okay, ni, dua ni, kena faham tu dulu. So based on these two things, the first equation, it talks about V2, V1. Maksudnya, dia melibatkan velocity 2, velocity 1. This is when we try to calculate or when we try to manipulate bahagian ini, the hypotenuse of the up version, where V2 is going to be here, V1 is going to be there. Itu yang pertama. Yang kedua, we have D equals to V1t plus half AT squared. This is the combination of D and then V1 is going to be here. Means equation number 2 talks about the down part. Okay, the down part. And equation number 3 is the combination of all those. So we are going to include kesemuanya. Dia macam tu. Sorry, this is not D. This is D. Vertical part. Kalau kita nak tengok semua, it's going to be the last equation. So this equation known as equation of constant acceleration. Okay, saya nak tunjukkan satu dulu pada kamu. And this is actually the way we prove things. Banyak Okay, now I'm going to show you, I'm going to prove that T up ni sama dengan T down, macam yang kita sembang-sembangkan tadi. Okay, we try to end up T up equals to T down by using equation of constant acceleration. Acceleration. Okay. Check equation dia. Equation dia adalah equation yang sama kita buat tadi. Okay, sini. Alright, so we start our equation with the first equation of constant acceleration. Yang pertama, which is V2 equals to V1 plus AT. Ni. Mana equation ni? Ni. Okay, V2 equals to V1 plus AT. Noted here, 2 and 1, this is not kuasa 2, kuasa 1. Kalau kuasa dia dekat atas. This is to show that this one is the final velocity, this one is the initial velocity. Okay. So based on this equation, we know that the first equation talks about the up parts. Okay, daripada starting sampailah apex. Okay. Alright. So this will serve as the angle. Jadi V2 dia dekat mana? V2 akan ada dekat atas. V1 akan ada dekat bawah. Okay. Now, please recall this thing first. Sin, cos, tangent. Sin will be opposite over hypotenuse. Cos will be adjacent over hypotenuse. Tan will be opposite over adjacent. Where this is opposite, this is adjacent, this is hypotenuse. Tu yang pertama dulu Okay, next one. We are going to substitute this thing. We don't have figures here. The thing that we know only several. First, V2. Abuk saya ni tulis kat atas. Aku cakap tadi jangan aku yang tulis. V2, V1. V2 will always equals to 0 because it is at the apex. A will be negative G. So tak ada figures Okay, and then V1. Can we have V1? Yes. V1 will always be V sin theta. Kenapa V sin theta? Okay, when we try to find V1, when an object move in a projection, projectile, it will move macam ni kan? It will move upwards. Meaning, it will involve both the hypotenuse ataupun resultant. Okay, this is known as resultant velocity. Why it is resultant? Because this velocity is the byproduct of horizontal component and vertical component. Jadi dia adalah resultant. Ingat tak benda semalam? R square equals to A square plus B square. So R equals to A square plus B square, the square root. Ni resultant. Okay, so untuk cari resultant, kita perlukan value dekat hypotenuse and value dekat vertical component. Why? Because we try to find out the first phase of projection, which is from the base to the peak. Jadi, bila kita nak tengok benda tu sampai ke atas, benda yang terlibat will be berapa jauh dia boleh pergi. Berapa jauh ke depan and berapa jauh ke atas. So, that is O and H. That is the reason kita pakai sin. So, jadilah dia V kali dengan sin theta. Because this movement is not straight macam ni. Kalau straight, V saja. Tapi kalau dia ada angle, we need to include the angle. Because based on the angle, the speed is going to be, there will be changes. Okay, itu yang pertama. Ini adalah 3 maklumat yang kita tahu. And we are going to substitute these 3 into the equation first. It will be 0 equals to V sin theta plus A negative G, and we have T. Since we try to prove that T up equals to T down, this T need to be transfer to the left hand side. Jadi nak transfer dia, kita transfer satu kolom ni. Kita mudahkan dulu. 0 equals to V sin theta negative GT. So we transfer the whole component to here. We are going to get GT equals to V sin theta. So T equals to V sine theta over G. This is T up. Okay. Jadi untuk kamu cari waktu T naik ni daripada base ke apex, you're going to use V sin theta over G. So kalau kamu dah ada value V, kamu dah ada projection height, kamu dah ada projection angle, kamu dah boleh determine the time taken from base to apex. T up. Satu. Okay. Boleh? I go slow ni. Can I proceed?
Boleh, sir.
Okay. And then, since we have T up, we try to prove T down. Okay. So, kita pakai equation yang kedua, which will calculate the second part of the projection. Okay. Ni second part, the down part. Okay. So, equation yang kedua ialah D equals to V1T plus half AT squared. Okay, betul Alright. Now, we know that it start here. So, V1 dekat atas means that we have the first information, V1 is 0 because dia dekat apex. Dia dekat apex. And then, second information is A, negative G. So, we are going to substitute these two information into here. So, we have D equals to 0 T plus half A T square. Okay, 0 dengan T, slash it out. Jadi, kamu tinggal D equals to negative half GT square. And as always, we try to find T kat sini. Okay, kita cuba untuk find the T here. Jadi, macam mana? Macam mana ni? Macam mana kita nak transfer dia? Okay, kalau pening, we go one by one. We go the first column first. The first column first. We go first with the first column. Transfer. Half negative. Negative half. Bila transfer sini, dia akan jadi positive 2 over 1. D equals to GT square. Now you have 2D sama dengan GT square. Jadi, T square sama dengan 2D over G. And T is 2D over G square root. This is first part of T down. Belum habis. Jadi kita baru sampai T equals to 2D over G square root. Okay, dia belum habis lagi. So we go to the third equation to solve this T. The third equation is the combination of both, which is V2 square equals to V1 square plus 2AD. Kita dah ada D kat sini. Kat sana pun ada D. Okay, now, when we go here, this one resemble the whole action. Okay, it resemble the whole action. Means that V1 will be here and V2 as the first one will be at the apex. So, macam equation pertama tadi, V1 is equals to V sin theta. Sama. Okay, pasal it still involve vertical component and it still involve the hypotenuse. Okay, and then V2 at the apex, it will be 0. And acceleration is negative G. So we are going to substitute everything into the equation again. Substitute all of this into here. So we have 0 square equals to V sin theta square plus negative G D. Okay, jadi kita dapat 0 equals to V sin theta square minus 2G D. Sampai situ. Okay. Apa yang sama dekat sini dengan belakang? We have D. We have D. Okay. Jadi kita nak keluarkan D ni dulu. So this D kita transfer. So we have 2GD equals to V sin theta square. So D is V sin theta square over 2G. Okay, now we substitute this value to T equals to 2D over G square root. Ni D ni. Yang kita dah ada value D, kita substitute. So you're going to get something like this. Sini T is equals to 2G. Okay, D tu kamu akan ada V sin theta square over 2G square root. Keluar pula. Okay. First, kita mudahkan dulu. So, you are going to get 2. Square root power of 2. Now, ni, G dengan G ni, macam mana bentuk dia sebenarnya? Kalau kita kembangkan bentuk ni, it will be something like this. V sin theta over G. Okay, ni saya tulis bentuk asal dia tadi. Sekejap. It will be something like this. Okay, kalau kata kita ambil bentuk asal ni kan, kita akan ada 2 V sin theta over 2G square G. Ni bentuk asal dia. Okay, so bila kita matikan square root and power 2, ni G dengan G ni, G dengan G, it is the same thing, it is the same value sebenarnya. So it become G sahaja. Jadi kita dah habis semua. Apa yang tinggal tu tulis balik je dekat bawah. So you have T equals to V sin theta. G dengan G is G. So it is G sahaja. Okay, ini kan, ni kalau kita tengok balik dia macam ni tau. 1 over G kali dengan G over 1. So it become G. Jadi kita end up dengan T equals to V sin theta over G. And this is actually the same as T up. Ni, V sin theta over G. So this is how you prove T up is equals to T down. Based on equation of constant acceleration. Itu bahagian pertama. Okay. And then, if you have come up until here, we are going to prove 45 degree is the best. Means that if you still using cos tan, we are going to end up dengan satu value equal to 1. Maximum value yang ada. Okay. To do so, we are going to use equation of distance. Okay. To measure distance. To measure distance of projection. Ni, D ni. Without using these two. So, kita nak tahu apa boleh pergi. Formula dia ialah, okay, so usually we are going to use R. Range equals to V cos theta T. And T here is T total. Means T up plus T down. So we have V sin theta plus V sin theta over G. Benda yang sama kita plus, kita akan dapat 2 V sin theta over G. Ni yang pertama. Okay, this is the first equation. Okay, So based on that, we are going to 2 V sin theta over G. Okay. We are going to calculate. We are going to substitute T ni dengan value ni. Jadi kita akan dapat R equals to V cos theta times with 2 V sin theta over G. Okay, darab masuk. Okay, bila kita darab masuk, V 2 kita tak didarab dengan apa-apa. Okay, tapi V kita boleh darab dengan V. This V dengan this V. You are going to get V square. Okay, lepas tu sin dengan cos. Tak edit apa. Dia akan jadi sin theta cos theta. It cannot be changed. Tak boleh nak mudahkan lagi dah. Over G. Okay, ni yang pertama. Alright. 2 sin theta cos theta ni kan. Kita ambil bahagian ni dulu. Kita mudahkan. 2 sin theta cos theta ni sama dengan sin 2 theta. Okay, ni matematik. Dulu-dulu je. 2 sin theta cos theta is equals to sin 2 theta. Kalau kamu kira, kamu akan dapat benda yang sama. Okay, dia permainan dia sebenarnya kat sini je. Dia akan dapat sin 2 theta. Okay, based on this one. Okay, based on this one. So, sin 2 theta sama dengan 2 sin theta cos theta. And then, next one is sin 2 theta ni, kalau kamu buka macam mana nak cakap the maximum value. The maximum value of sin, kita sekarang nak maximum value dia 1. So, kalau sin 2 theta sama dengan 1, you try to find this one. You're going to end up dengan sin 90. Betul tak? 90 sin 1. So, if sin 90 ialah sin 2 theta, okay, so sin theta sama dengan berapa? Kalau sin 2 theta, 2 theta ni maksudnya 2 kali certain angle, ialah 90. Means, kalau theta saja, it will be 90 bahagi dengan 2. Means, you're going to get 45. Okay, now let's try. 45 sin 45 degree. Ini value dia, 0.7 something. Okay, and this actually prove that 45 degree is the best angle based on value ni sin 90. Okay, this is sin 45. Kita nak 90. Because 90 ialah 1. But based on the equation, in order for you to find out range tadi, R, lepas kita buat pengamiran ni, kita end up dengan R equals to V square sin 2 theta over G. This is how you want to find R. Jadi, kalau cos theta ni kita letak 90, sin 2 kali 90. So, kamu akan dapat 2 kali 90, 180, sin, kosong. So, the best angle here is 2 kali 45. Sin. So, you akan dapat 1. Means that if you have 45 degree as the angle here, you are going to get the most range if you able to control the velocity. So, lagi laju initial velocity sini, lagi jauh dia boleh pergi. This is how you prove the best angle for projection where the projection height is equal is 45 degree. Okay. Sampai situ sahaja dulu untuk hari ini. Ada soalan? Ui, bunyi apa tu? Azan
So far okay, sir.
Tiba-tiba bunyi macam azan. Okay. So far, okay, alright. So we are going to stop here. Equation of constant acceleration. So up until today, we have learned a bit about the projection, factor affecting projection, and how we want to prove that T up equals to T down. At the same time, what is the best angle to get the best range. Later today, later next week, we are going to continue on several questions on how we want to use equation of constant acceleration. Konsep dia sama. Kalau kata kita cari benda yang naik dekat apex, V2 akan jadi kosong. So the concept will be quite similar. If you don't have any more question, this will serve as the end of our class today. And we are going to meet again next week, Tuesday, with some continuation of this topic. And we're going to start next topic next week. Thank you again for your participation. Don't forget to take your attendance. Assalamualaikum and very good evening to all.